Welcome back. This session is the continuation from the previous session. At the previous session, I have created all the CAD parts of the VREP Smart Raspberry Pi 4 robot, and in this session all those CAD parts will be imported in .stl file format. Those .stl file format then will be used in VREP. .stl file format doesn't have any physical properties. The physical properties in VREP engine is given by the primitive shapes. These primitive shapes are really easy for the physics engine to compute all the physical properties. For instance, collision avoidance, center of the gravity, and all other physical interaction. The way it works is that the imported .stl files will be working as the flesh, but the skeleton, which takes all the physical interaction, are the primitive shapes. .stl files will be overlaid on top of the primitive shapes. The close analogy can be given as that flesh and bone. Flesh are overlaid on top of the skeleton. Flesh goes wherever the skeleton goes. Same goes for this VREP physics engine. .stl files are the flesh and the bones are the primitive shapes. Now here the primitive shapes, you can't see this thing because I have turned off the visualization, and I turned on the visualization of the .stl files. As you can see, this is my completed robot. With .stl files, I give all the visual parameters. I have colored them as accordance to their real life parts. This is my Raspberry Pi 4 computer. Now in VREP file, I give it all the physical properties of the real Raspberry Pi 4 computer. I also give it a casing as well. In my real life Raspberry Pi 4 computer has got the heatsink casing, which is made of brass, and the color is goldish yellow. Now in VREP file, I give it the same color as my physical robot, so it has got the brass color itself. And also you can see all the other ports as well, like USB ports, the HDMI ports, and the power cord, everything. So it is resembling 100% resemblance, I would say, with the physical robot. I will show the best way to import a CAD file to VREP file. So the file, right click, import mesh, then it give me the folder where all the CAD parts I previously created are located. I am choosing this motor controller board CAD file, then it is imported, and I'm giving it a scale. So I'm giving it the scale of centimeter scale. You can see all the IO ports, capacitors, inductors, motor ports, and power cord cable are located, is visualized in these CAD parts. Now go edit, and that object manipulation, I will divide this in different shapes. So group merging, divide selected shapes. So these are completely different. All the components are now independent on their own. You can see the power control, the power control port is selected. As I am hovering the mouse on top of it, same goes for the solid capacitors, motor control, motor IO. Now I'll go edit again, and this time so these are few of the options you will see when you go on edit mode. You can select make selected object as orphan, morph selected into convex shapes, morph selected object into other parameters as well. And as you can see, these are the STL files divided in different geometric entity. This geometric entity then can be manipulated and customized for our physics engine. The way it is really easy to compute it, and you can also color them. So adjust color, then ambient component, and we can change each individual parts color as well. completed, I will convert them to a one entity, because it is really difficult for physics engine, the computer CPU itself, to calculate every part's location and coordination in the physical completed parts. So I need to convert it to one part, the whole visualization thingy, because these parts, there is no way or meaning represent the actual physical physics engine parts, because physics engine parts are interact with the geometric primitive shapes. So here I am selecting all of them one by one. Once all the parts are selected, and give it a name as motor controller. This is the complete part, which in one section it is not divided in multiple parts, multiple components anymore. It is really easy for physics engine to interact with this part. Next section, I will show you the completed car, but you need to give it a name. So the way you give the name is that you write motor controller. This is my completed physical arena, and this is the completed car, where you can see the Raspberry Pi 4 on top with the battery, camera, buck converter, and this is my motor controller, which we just was talking about all along. Now I go inside and explore all the primitive shapes. So the base plate is that actual primitive shapes. I'll make it visual. To make it visual, I need to go common, then the top layer is that actual visualization. So I turn off the top layer. So all the .stl file I have just imported and created, they are gone. They are not been shown in here. You can see now I'm making the visualization on for the primitive shape. This rectangle representing the center of the mass of the robotic car. With 4 motor overlaid. Same goes for the wheels as well. The .stl wheels are for visualization, but the actual wheels are like but the actual wheel look like this. Now I get the visualization on for the .stl file, and I put the visualization off for the motor and as well as that primitive shape wheel. For motor is visualized in this case, but the primitive shape wheel is the 4 motors. 4 motors are visualized here, but the primitive wheels visualization has been turned off. Let's explore some of the Lua code behind this. I used Python for running this robot, but the Lua code, some aspect need to be redirected for that Python code. All the script you can explore with this button, with the script icon at the left hand side of the corner. If you click on the screen icon, I open the main script. As you can see, I commented all the relevant script which are supposed to be running this robot in Lua programming language, but only the CMX remote API start integrating a port has been initialized. So this will talk with the Python programming language. The Python programming language will be on in the computer, same time the VREP programming language will be on as well. So they will talk to each other. VREP will show the visualization and Python will be providing all the command. I think that's all for today. Thank you for watching my video, and if you need this code, I'll be publishing it in GitHub, but meanwhile if you need this code, you can comment me. I will email it to you. Thank you for watching. I will see you at next time. Thanks.